See about the motion on a plane, and we'll continue this chapter today also. One thing is your position time relation. While an object or a particle is moving on a plane, we'll try to find out a relation between the position and time. We know the velocity of the body is uniform. We'll consider uniform uniform velocity. So the velocity of the body is uniform. Velocity velocity of the body is uniform if the change in the displacement, if the change in the displacement, change in displacement is is equal at equal interval of time. Interval of time. So we'll draw a figure now. So this is y-axis and this is x-axis. We will take three positions of a particle while moving on a plane. Suppose the particle is moving like this. Particle is moving like this. So we consider the initial position. Suppose this is a P0. This is P0 denoted by or x0, y0. Another position here at P. Suppose say this is x1, y1. Another position at Q. Suppose this is Q. Another position Q, where the coordinate of the point, that is x2. X2. So we can find the position vector of these three positions while the particle is moving along this path. So this is your origin. So the axis. This is your O 0 0, and this is your P0. Then this is your OP, and this is your OQ. Suppose say Q. This is your Q. So the position vector of these particle at three positions is like this. Suppose this is, we represent this position vector at R0, and this is R1, this is your R1, and this is your R2. This is R2. Then what is B is equal to? What is your V? V is equal to V is equal to this mass R2 minus R1. R2 minus R1. So this is R2 minus R1. And when the particle has P0, suppose this is at 0 time, and when it is at x1, y1, the time is t1, while at q, this is at t2. So the time interval is here t2 minus t1. So p is equal to r2 minus r1 divided by r2 minus r1. So we can v t2 minus t1 is equal to r2 minus r1. So your r2 will be what will be the r2? This r2, you write first r2 equal to r1 plus v t2 minus t1. So if the your p is at origin, if you take p at origin, then what will happen? P is at origin means you can write that is what this R1, this is coincides at this. That means your x1 becomes 0 when the P point P is at origin. Then when the P point is at origin, then you can write x1 equal to 0, y1 is 0, and P1 is equal to 0. So at that time, you can write R2 in general, you can write R2 is equal to R. This R2 may be R, and this is R0. Or you can write R2 is equal to R0 R0 plus V T2, or in general you can write T T2 T2 is equal to T1 is equal to T. So you can write in general you can write or R is equal to R0 plus V T2. So this in general you can write R is equal to R0 plus V Vt. This is the case when the particle has origin, as moving from origin. And in this case, we can write these things in rectangular forms. So first, In that case, you can write R. In general, you can R and the x2, x2, y2 will be x in general. I can simplify this figure again. This is your R and this is R0. So then got the relation like this. R is equal to R0 plus B. So what is R is equal to here? R is equal to x I cap plus y j cap. And what is R0 is equal to? R0 is equal to x 0 I cap plus y 0 j cap. And V is equal to what will be V? V is equal to Vx I cap. So V will be that V will be Vx I cap. V will be corresponding V will be Vx I cap plus V sorry Vy j cap. Vy j cap. So we can write this equation as like this for x I cap plus y j cap is equal to x0 I cap plus y0 j cap plus vx I cap plus vy j cap. So we can simplify this. Where your vx and vy, this vx and vy at the x component and y component of the velocity at this point q. And the total expression will be like this. If it is not in the origin, into t, this is t. This vt and this is t is multiplied. It is total equation is x I x I cap plus y j cap is equal to x0 I cap plus y0 j cap into vx I cap plus vy j cap into t. If the particle starts moving from origin, this is the expression. We will continue this chapter in the next class. Thank you.